Hey everyone, this is Alex from wornoffkeys.com, and this video is going to be an entire module taken from my complete JavaScript course. If you want to check out the full course to see if it'll help you, it'll be the top link in the description down below. I'll have some more information on the course at the end of the video, but before I get into that, let's just jump right into the training. We're now going to take a look at asynchronous versus synchronous code and the concepts behind the two. JavaScript is a synchronous language, which means everything is ran line by line. For example, if I add in a console log and I print start, I add in another console log and I print end, if I save this in our console, as expected, we get start and end. Now let's add in a simple for loop in between these. Like I say, for, let a equals 0, while a is less than 10, we can increase a. I'm not going to have anything inside the curly braces for this for loop, but if we save this, we basically get the same result. And that's because counting from 0 to 10 is very fast, but let's say I wanted to count from 0 to a billion. Well, I can add in underscores here to separate these zeros, so I can add in 9 zeros very easily. If you didn't know, you can add in underscores into your numbers, and JavaScript will basically ignore them. This is similar to writing commas in the real world to make it easier to read large numbers. So if I add back my underscores and I save this, we see a slight delay in the console. So let me try this one more time. Here we see a slight delay. So JavaScript code will start at the top of the file. In this case, we're running console.log start, which is practically instant. And after this line is done, it will then go on to the next line. In this case, we're looping from 0 to a billion, and it takes a second or two. So the code is going to wait here, or is technically known as blocking, until this entire expression is done. Now afterwards, it'll continue on. In this case, it's on a console log, which just prints out into the console. So this is synchronous code, and basically it's just one line at a time. Now, asynchronous code is going to be doing multiple things at the same time or delaying certain actions until a further time. And this is exactly what we'll be diving into throughout this module, how to write and understand asynchronous code. We're now going to take a look at setTimeout and setInterval and how synchronous code works around these functions. So I'm going to make my own function, and this can be a standard function with a function keyword or by using arrow functions. So I could say const hello equals an arrow function. And within here, I'm simply just going to console log hello world. Now below this, I'm going to say setTimeout, and this takes in two arguments. The first one is a reference to a function, and the second one is a time in milliseconds. So for the reference, we just pass in hello, and we do not pass in the parentheses, because this means that we're going to run this function. And then with that said, the result or the returned value of this function we passed in instead, which in this case is undefined because we're not returning anything in this function. But this is incorrect. We only want to pass in the name of the function. Now afterwards, this is going to be the delay to wait until we run this function. And this will be in milliseconds. So every 1000 milliseconds equals 1 second. So if I want to wait 2 seconds, I can add in 2000. If I save this, we now wait 2 seconds and then we see hello world on the screen. Now let's go ahead and add in a few console logs around this. So I can say console.log start. At the bottom, I could say console.log end. Before I run this, what do you think we printed? Well, if I save this, we see start, end, and then hello world. So as I mentioned in the previous video with that large for loop, JavaScript will block all synchronous code, but setTimeout is going to run this asynchronously. So behind the scenes, it's going to continue to let the code execution run just like normal, but it'll just happen to run this function here 2 seconds later. So now let's take a look at what would happen if we had additional arguments on this hello function. So for example, I could say text, and I can add on text. Well, if I save this as is, we see start, end, and then hello undefined, because we're never passing anything into text. Within setTimeout, any additional arguments you passed in will be passed into the target function. So I could say world right here. If I save this, we will now see hello world. Now this is using a named arrow function, as you can see here, but the most common use case for these types of functions is known as an anonymous arrow function. So I'm going to reference this directly inside of here, just like a normal arrow function, but without a name. I'm also going to get rid of world at the end. And now within here, I'm just going to console log hello world. So if I save this, we see start, end, and after 2 seconds, we now see hello world. So now that we understand setTimeout and how it can delay a function execution, let's go ahead and take a look at setInterval, which is the same thing in every way. Aside from this is now going to be a repeated task every 2 seconds, rather than just running it once. So when it comes to passing in functions, when it comes to the additional arguments, everything else is the same, but you'll see the main difference whenever I run the code. So setInterval. If I save this, we now see start, end, and then hello world. And then 2 seconds later, we see hello world again. And then 2 seconds later, we see it again. Now, the reason why there's a number counting right here is because in Chrome, it's not going to just spam a bunch of the same messages. It's going to stack those together. To get around this, I can add on a new date object. And if I save this, we're now going to see unique strings printed to the console with the specific time. So this is 26 seconds, 28 seconds, and so on. And so because these are different strings, Chrome is not going to auto stack them together. So as you can see, the setInterval function is going to run our anonymous arrow function here once every 2 seconds. Now, functions passed in this way are known as callback functions. Essentially, they're a function that's passed in that will eventually be called back to at a later time. In the last video, I mentioned that the functions we pass into setTimeout and setInterval are called callbacks. In this video, we'll look at a concept known as callback hell, which is where your code becomes almost unreadable and very hard to maintain. So let's say I want to go ahead and add in a countdown from 5 to 0, so counting 5, 4, 3, 2, 1, but I want to use setTimeout. So I could say setTimeout, we have our anonymous arrow function, and we're going to run this in 1 second. I can now add in a console log to print out 5, and now in this function, I can add in another timeout. So I'm actually just going to copy this and paste it right in here, and change this to 4, and I'm going to paste this in again, and change it to 3, and paste it again, 2, and finally paste it again, 1. If I save this in our console, we see 5, 4, 3, 2, 1. So it works, but this code is very hard to maintain. And this is just a very simple countdown. Imagine if each one of these were trying to reach out to an external API to perhaps fetch some information about customers, or trying to find information on a movie or other things like that. If you're having to fetch a bunch of things at once like this, then there are much better ways to solve this problem. And we'll be looking at a couple different solutions in the next few videos. We're now going to talk about promises, which are the main solution to avoiding a lot of callbacks, also known as callback hell, which we took a look at in the last video. There are two main use cases when it comes to promises. The first is going to be creating them, and the second is going to be using them. So we're going to start off by creating our own promises, and afterwards I'll show you how to use those promises. And most of the time, whenever you're working on your own projects, you'll be using a promise that's provided to you, often when fetching data from an external API. So as a hypothetical example, let's say I'm trying to access some information from my own API, and if you don't know what an API is, it's basically a way for your code to talk to other code. So let's say I'm trying to access information about a user who is signed up for my software. And then let's also say, separately, in a different promise, I'm looking to access payment history from that user. So we'll start with just fetching the normal user. I could say const user promise equals a new promise with a capital P, and within here we can add in an anonymous arrow function. Now this is a special type of function because it has two built-in parameters. The first is called resolve, and the second is called reject. So similar to promises in real life, once this promise is made, it can either be kept or it can be broken. Resolve is called once everything went well, therefore the promise was kept, and reject is called whenever something went wrong, therefore the promise was broken. But either way, this code here should resolve or reject something at some point. So within here, we just have a normal function, and because I explained the example of fetching a user from a database, in reality, there is a slight delay when that happens. So I'm going to simulate that delay by using setTimeout. So I could say setTimeout, we have our function here, and let's say this takes 1000 milliseconds in order to access the information from our database. Again, if you're not aware of how to fetch things from a database or anything like that, don't worry, this is all just hypothetical. Just imagine you're trying to go to your profile page on Netflix or some other type of paid subscription, and it's trying to fetch information about your user, and then we also want to fetch payment history for your user. So hypothetically, this will take 1 second to get, and then let's say that I have access to the user information. So I could say user equals an object, where the name is Alex, the age is 28. Now in this hypothetical situation, this user might be returned as null. So I want to check for that. So I could say if user exists, we can now resolve and pass in our user. When calling resolve or reject, you can pass in anything you want into these functions. And later on in the video, once we get to using functions, you'll see how that data is then handled. So if user exists, we're going to resolve. Otherwise, we're going to reject. Now you can pass in something such as unknown user, or you can pass in your own error. So I could say new error with a capital E, and here I could say unknown user. The benefit of doing this is that this gives us a line number in our console. So I'm going to go ahead and add in a console log. This will say start. I'll copy this At the bottom of my file, I'll say console log end, and then in between these, I'm going to say console.log user promise. So if I save this, we now see start, promise pending, and then end. We can actually expand the promise here. And if we expand it again, we now see catch, constructor, finally, and then as functions. Then is called whenever resolve is called, and catch is called whenever reject is called. And similar to try catch, we have a finally here that is called no matter what. But most often you're going to be using then and catch. So now I'm going to create another promise about payment history. So I can say const payment promise equals a new promise. We'll add in our functions here, and we're going to keep this one fairly simple, but we still need our resolve and our reject. I'm going to add in setTimeout, and let's assume that this takes a little bit longer. Let's say that this takes 3 seconds. So now within here, I'm simply just going to resolve with an object, and we can just say the lifetime value of this customer has been $100. And we could add in a bunch more things, such as payments for each month, but I'm going to keep this fairly simple and just have one object here. So now I can add in a console log, and we can print out payment promise, and we'll see the exact same thing. Here, we'll still see catch, constructor, finally, and then, same as if we saw this right here. So these promises say pending, even though we're resolving or rejecting within them. The reason for that is that we're not actually handling the resolved call or handling the rejected call. To do that, we have to pass in our own callback functions into .then or .catch. So now I'm going to delete these console logs right here, and we're going to take a look at how to actually use these promises. So we'll start with the payment promise just because it's right here. I could say payment promise .then, and we can pass in our own anonymous error function. And typically for readability, you would put .then and .catch on their own lines and tabbed in one time. So I could say .catch in a very similar way. So .then is called whenever something worked. So in this case, I can say payment history. I can add in a console log to console log the payment history. Now under catch, I can have an error. I can say console.error and print out the error. Now in this case, we're not actually having an error at all, but it's always good to add in a .catch just in case something wrong happens, because of course, this is a very basic example, and in the real world, there's many things that can go wrong with your promises. So I'm going to save this. We now see start, end, and then after 3 seconds, we are going to see this object returned right here that says lifetime value of 100. So that delay here was because we're waiting 3 seconds to simulate an actual API call. Because these things are not instant, in real life, your software would be communicating with some external software, probably hosted around the world, and then it would return something back to you. So in reality, setTimeout is only here to simulate that delay. So here we have our payment promise. Let's go up and let's actually look at our user promise. So I can say user promise .then. Here we'll have our user, and we'll just simply add in a console log to print out user. And then we have .catch. Here we're going to have our error. I'm going to say console.error. We're going to have our error. Now, as an example, I'm going to add in finally, and this will just simply add in a console log that says finally ran. So if I save this, here within 1 second, we're going to see this user object returned. And then 2 seconds later, because of the difference between 1 and 3 seconds, we are then going to see our lifetime value returned. So here's the user object that we have right here. I'm now going to comment this out, and I'm going to say const user equals null. So therefore, this if statement will be false, and we're going to actually reject. So if I save this, 1 second later, we get this error here, and it says index.js line 16, which is where the error actually came from. So this is going to be how you handle your promises with .then and .catch, as well as .finally, but as you can see, finally ran was always ran, whether something worked or didn't work. Typically, you won't have finally here, but just in case you need it for whatever reason, you now know that it exists. So let's say that I want to access both the user and the payment history at the same time. In this case, there is a slight delay between the two because it's taking 1 second to fetch my user in this hypothetical example, and it's taking 3 seconds to fetch the payment history. Well, I'm going to go ahead and comment out the .then .catch for each promise, and I am now going to use something called promise all. So I can say promise.all. This is a function that takes in an array, and I can pass in each individual promise that I want to resolve. In this case, it'll be the payment promise as well as the user promise. So I can say user promise and payment promise. And this returns its own promise where we have .then and .catch as well. So I can say .then, here we have our data. I can add in a console log to print data to the console, and .catch, here we have our error. I can say console.error and print out our error. Now, one thing to keep in mind in this exact example is that here we have access to our data variable. And the only thing we're doing right now is just console logging it. One thing we can do is just pass in console log as a reference here and it'll have the same exact result. The reason for this is that in reality, our callback here is just passing in a reference to this function anyways, and it's calling that and then passing in the parameter into the console log parameter. So the same exact thing can happen if I just add in console log right here. And obviously console.error works the same way. So these two lines here have the same exact result as the other two lines just beforehand. This works with all callbacks, not just promises. It's not actually related to promises at all, but I wanted to quickly mention that for those who didn't know. So now if I save this, we see start, end, and then unknown user. So .catch was ran right here. Now if I go back and I uncomment this right here, and I comment out the null, so user actually exists now, and I save this, after 3 seconds, we're going to get both responses back. So here we have a 1 second wait for the user info and a 3 second wait for the payment info. So what this will do is it'll run all of them at the same time, and then once all of them have returned their responses, then we're going to use .then or .catch. So basically it's going to have a delay that's the longest one possible, in this case 3 seconds. So in here we have an array. If I expand this, the first element is going to be our object, and the second element is going to be our lifetime value. So within this .then right here, we then have all information we want from both promises. Now this works pretty well, but as you saw from .then and .catch, we are still using callback functions, and so therefore it's slightly similar to callback hell if you keep nesting these inside of each other. In the next video, I'm going to show you the cleanest way to avoid all this while still using asynchronous code and promises. So far in this module, we've taken a look at different ways to write asynchronous code. In the last video, we had a look at promises, but we noticed that we're still using callbacks, which is something you might not want to do. What if you could write your asynchronous code in a synchronous way? Well, that's what the async and await keywords are here for. So I'm going to start off by making my own function. So I can say const fetch user. This will be an arrow function, and I'm going to return a new promise. So I can say return new promise. We have our function inside with our resolve and reject keywords. Now, similar to the last video, I'm going to use setTimeout here to simulate a 1 second delay. So setTimeout, we have our arrow function here, and then 1000 milliseconds. Now within here, I'm going to create a user object where the name is Alex and the age is 28. And then I'm going to resolve passing in that user object. Now you often will have a case for rejecting, but in this case I don't, so I can actually remove this here. So now that I have this, I want to create another function. This will be called get profile info. And this function here is going to call fetch user. So I'm going to add in const user equals fetch user. And then I'm going to call console log and print out user. And then I'm going to call this function. So get profile info with parentheses. And if I save this, we now see a pending promise. So of course, if we wanted to access the user, we would have to use .then after this. So I could say .then console log. If I save this, we now see a promise that's pending because that's what is immediately returned. However, just accessing the return of a promise isn't going to give us the result immediately. We have to use .then. Well, this is where async and await come in. Instead of .then, I can say await right here. And because I'm using await, this function has to be declared as asynchronous. So I can say async beforehand. So now if I save this, nothing's printed to the console until the response is actually gotten. So our asynchronous code is forced to act like synchronous code. To prove this, I can add in a console log here that says start, and then I can add in a console log below this that says end. And if I save this, we see start, there's a 1 second delay, then we see end and then the user. So similar to synchronous code, this will run this line here, and then run this line here. And because of the await keyword, we're going to sit here and block or wait for this to actually finish processing. Then we're going to look at the rest of the code, such as this console log and this console log here. So if you don't care about the results of your asynchronous code, you might as well just get rid of this await right here. And if I save this, then we see a promise pending, and we're not going to actually get anything from the user. You'll often see this type of syntax whenever you're sending things known as post requests, which are beyond the scope of this module, but it's essentially where you go to update or create things such as users or new posts and other things like that. However, if you do care about the results, you will have to use await. But even with all this said, what is this async keyword? Well, if I remove this and I save the file, we actually get an error saying that await is only valid in async functions. So if I bring this back, I now want to show you what actually happens to this function. So I'm going to get the results of this function. Like I say, const results equals the response of this, and I can console log results. Now to simplify and clean up my console, I'm going to get rid of start and end, and also this console log here. Now, if I save this, we get a pending promise. And if I comment out this remaining line and I save it, we now get a fulfilled promise that is fulfilling undefined. If I get rid of async here, we just get undefined. So async will force this function to always return a promise. Even if I'm returning something like a string, let's say test, and I save this, we now see that the promise is fulfilled immediately and the response is test. So async will make this function always return a promise even when we're not explicitly telling it to. Now later on in the course, when we go to make our own projects, you'll see how all of this asynchronous code works when it comes to real API requests. So that was the end of the module. The full course has many more modules covering every topic in vanilla JavaScript. And each of those modules has its own ending quiz to test your knowledge. You'll learn how to build multiple real-world projects throughout the course. And if you ever get stuck and need help, there are multiple ways to get in contact with me to ask your questions. On top of that, you'll get lifetime access to all premium source code downloads from the channel, which is something you currently have to pay monthly for through Patreon or as a YouTube member. And finally, all of that is backed by a 30-day money-back guarantee. So if you're not completely satisfied and you're not effectively learning JavaScript, then you don't pay a single cent. So if you want to check out the full course, it is linked in the description down below.